Okay, this is study guide 4, problem number 4. The relation R is an equivalence relation on the set A. Find the distinct equivalence classes of R. The set A contains A, B, C, and D. And the R has those points. So I'm going to, as I will with problems that are, this is going to be fairly easy for me to draw one of these graphs here where I'm putting A, B, C, and D. I'm just going to draw the graph. To me, it's easier that way. So I have A going to A. I have B going to B. I have B going to D. I have C going to C. I have D going to B. And I have D going to D. Okay? So as an aside, I know this is not part of this problem, but I just want to sort of just use this problem to answer 3 questions first, just to sort of show you, get a little bit more experience. I'm just going to ask real fast if this is reflexive, if this is symmetric, and if this is transitive. Okay? So reflexive just means that every element maps back to itself. So A maps to A, B maps to B, C maps to C, and D maps to B. So D maps to D. So it is reflexive. Symmetric just means every time we have an arrow going in one direction, like from B to D, we have an arrow going in the opposite direction, D to B. And we have that because there's only these arrows here. And transitive means anytime there's a 2-step process, we can create a shortcut. And the only time that's happening is in trivial times. For instance, B maps to B and B maps to D. So we're asking the question, does B map to D? Well, sure it does, because that's what this point is doing. Okay? So again, I'm just, just as extra practice, I'm just pointing out that this is in fact equivalence class because it is reflexive, symmetric, and transitive. All right, so let me delete those things. All right, and now we're going to find the equivalence equivalence classes, the distinct ones. So I'm just going to put these braces around every element in A, like so. And I'm going to start with A. Well, how many points go? Don't forget equivalence classes this is where it's going. All right, well, it starts at A, so this is the set containing A. That's the only thing going to A. Well, how about B? Well, there's one going to B itself, right? And there's also D that goes to B. So we'll put D here. Now for C, the only thing going to C is itself. And finally with D, we have B going to D. And we also have D going to itself. And I would recommend when you're doing this to do it in alphabetical, like in this case, do it in alphabetical order or descending. Whatever order you do, just keep the same order because then it's easy to see which ones are equivalent. A is by itself, B and D are the same, and C is by itself. So the final answer here, because we want distinct equivalence classes, is just to rewrite A as being the set of its, set containing itself. B is equal to D is equal to the set containing BD. And finally, C is the set containing itself. And that is the final answer.